Howdy there, Mr. Sutton here, bringing you the AB Calculus 2-8 Extra Practice number 3 solutions on rate of change. On this problem, we're trying to write an expression for f prime of x for this function over here. So to get the derivative, let's first write the general form of the derivative, at least in limit form. So that would be the limit as h approaches 0 of f of x plus h minus f of x all over h. So basically, we just have to take this stuff and plug x plus h and x into it and put it in this formula here. So I've got a big fraction, limit as h approaches 0 all over h. And now upstairs, instead of writing f of x plus h, I'm going to write absolute value of 2 parentheses x plus h minus 5. And then over here, I'm going to have minus e to the secant of x plus h. And I'll just do all of this stuff minus f of x, which is just the original function in a big parentheses. On this problem, they want an expression for the slope of the tangent line for this function right here. So slope of a tangent line, we're basically talking instantaneous rate of change. So let me write out the IROC formula. Limit as h approaches 0 of f of x plus h over minus f of x all over h. And so basically, I'm just going to take this formula and I'm going to use it on this formula. So I'm going to plug x plus h in here. I'm going to write all that out, and then I'm going to subtract f of x. So I end up with the limit as h approaches 0, big fraction all over h. And now f of x plus h, well, that's going to be the fourth root of parentheses x plus h to the 7th minus 6 times log of x plus h. And from this, I'm just going to subtract f of x, which is just all of this stuff in a big parentheses. On this problem, I'm given selected values of some function f in this table. We want an answer choice that gives us the average rate of change of f over the interval from 1 to 5. So this is basically just y2 minus y1 over x2 minus x1, essentially just slope. So for this particular problem, we're going to be doing f of 5 minus f of 1 over 5 minus 1. And f of 5 in the table, just looking that up, that's 14. f of 1 is 2, so we have 14 minus 2 over 5 minus 1. And we could simplify it, but one of the answer choices is just that. So we're just going to stop and pick answer choice C. On this problem, given this graph of f, we want the average rate of change of f over the interval from -1 to +6. So we're basically doing the slope of a line that goes from -1 to +6, which you can see very clearly is going to be just a horizontal line, so that's actually just 0. But if we wanted to show our work and write a little bit more out, we could say the average rate of change is going to be f of 6 minus f of -1 over 6 minus -1, or 6 plus 1. So that's going to be, let's see, 6 plus 1 down there, and on top, f of 6 right here is just 0. f of -1 is also 0, so we've got 0 minus 0 is just 0 over 6 plus 1. So that all comes out to 0, just like we could see visually, and that's going to give us choice B. For this problem, we're given a function f as 1 plus 3 cosine of x. We want the AROC, the average rate of change of this function, over the interval from 0 to pi. So our general setup, we're just going to use basically a slope formula here from one end of this interval to the other. So we've got f of pi minus f of 0 over pi minus 0. And let's see here, f of pi, well, that's going to be 1 plus 3 times cosine of pi. Cosine of pi is -1, so that's 1 minus 3, which is going to be -2. And then f of 0, well, cosine of 0 is 1. 3 times 1 is 3. 1 plus 3 is 4. So we're subtracting 4. So this comes out to -6 over pi, which is going to give us choice A. On this problem, the derivative of a function f is given by f prime of x equals -3x plus 4. So this is a formula for the derivative at any x value. You just have to plug it into this formula. And we're also told f of -1 is 6. Which of the following is the equation of the tangent line for the graph of f at x equals -1? So if we want an equation for a tangent line, we need to know the slope of the tangent line, which is just going to be the derivative at -1. So we need to figure out f prime of -1. To do that, we just have to plug -1 into this formula. So that's going to be -3 times -1 plus 4, which gives us a derivative, a tangent line slope, of +7. At this point, we have enough information to write an equation. We're going to start off by writing this in point slope form. So y minus y1 equals m times x minus x1. This is a good place to start because you just need a point and a slope, and we have both. So we've got y minus the y value that they gave us, which is 6, because they told us f of -1 equals 6. So that point is on the graph. So y minus 6 equals the slope that we just found, the f prime 7. And then we have x minus the x value we plugged in, which was -1. So that's actually x plus 1. So this doesn't match any of the answer choices, because these are all in slope-intercept form. So we're going to convert this into that form. I'll start by distributing the 7. So that's going to give me a 7x over here. And I'll also have a plus 7. But if I add the 6 over here, that becomes a plus 13. So then that ends up giving me answer choice D. On this problem, they're giving us the graph of f prime, which is the derivative of a graph of f that they're not showing us. They're also telling us the points 2, 6 and 4, 18 are on the original graph of f. So based off of that, which of these is the equation of the tangent line for the graph of f at x equals 2? So to get a tangent line equation, we need a point and a slope, and then we can plug it into the point slope formula. We've sort of got a point, 2, 6. They're saying the x value 2, so 6 goes with that. So that's the point we're going to plug in, but we need a slope. That would be the derivative of our function at x equals 2. So we need to find f prime of 2. Well, the good news is they gave us a graph of f prime. So if you just plug in the x value 2 and look that up on the f prime graph, that looks to be a value of 5 right there. Okay, let's plug everything into point slope now. So that's going to be y minus y1 equals m times x minus x1. So we've got y minus the y value 6, slope of 5, that was the f prime that we just found there, and x minus the x value 2. Now, unfortunately, this doesn't match any of the answer choices. So we're going to have to convert this into slope-intercept form. We can do that by distributing this 5. So that'll give us a 5x and a minus 10. But if we add the 6 over here to get y by itself, -10 plus 6 ends up giving us -4. So that ends up giving us answer choice B. On this problem, we're given the graph of a trigonometric function f on the interval from a to b, which they're not really telling us what that is, but whatever. At which of the points on the graph could the instantaneous rate of change equal the average rate of change over the interval from a to b? So we're basically asking, where is the I rock going to be the same as the a rock for this whole interval? To make things a little easier visually, it helps to draw out what the slope of the average rate of change should look like. So that's just going to be the slope of a secant line that connects the beginning and the end of the function. So if we just draw a line from here down to here, like so, so there's our secant line, our average rate of change slope. So we see at the very least, in order to match the average rate of change, the I rock must have a negative slope. So already that's going to rule out choice A, which has, it looks like a 0 slope or maybe a slightly positive one. Choice D has a positive slope, so that's also no good. So now we're picking between choices B and C. And I think at this point it's easiest if you just draw some tangent lines on those and see which comes closest to matching the secant line that you just drew. So here's the tangent line on B, roughly, as well as I can draw it anyway. And here is C. It's a little bit steeper. Now if you just compare these to the secant line, the C slope there, the tangent line at C, is a little bit too steep. So really the best answer here is going to be choice B. For this function, we're given a graph of f and told we have a discontinuity due to a vertical asymptote at x equals 6. We also have this continuous increasing function g represented in the table here. And for the first task on this problem, this free response problem, we want to use the graph of f and the table to estimate limit as x approaches 0 of f of x minus g of x. So for this one, the trick is you can actually split this up into two different limits. You can just take the limit of each of these items individually and subtract those limits like so. And we're approximating this, so we're going to write approximately equals in a minute. But let's get the limit as x approaches 0 of f of x. So looking at my graph, as we approach 0 from the left and the right side, we are approaching the y value 2. So that's going to be 2. And now this next one is why I have to write approximately equals g of x limit. All we have to go on is this table, and tables aren't always the most reliable thing because you never really know what's happening in between the values. But on this table, we do know that this is a continuous and increasing function. So if we're looking for the limit as x approaches 0 on this table, as we approach the x value 0 from the left and from the right, we appear to be approaching the y value 2. So we're going to write 2 for this. So this is approximately 2. I mean, we don't really know what the limit is for sure, but we do know that 2 at least falls somewhere in between 1.999 and 2.001. Because this is continuous and increasing, we know we are going to pass through 2 somewhere on this interval. So it's a pretty good approximation. And if you just want to simplify that, that comes out to 0. For this part of the problem, part B, we're given the values 1, 2, 4, and 6 and asked to find the limit of f at those values. So let's go through each of them one at a time. For 1, so looking at the table, here's the 1 value. So we're going to do the left versus the right limit on this. Left side limit as x approaches 1 is going to be, let's see, the value 1. That's the y value we're approaching. If we approach 1 from the right side, we are approaching the value 0. And I mean, you can look at this graph and tell clearly that the limit does not exist, but this is a good way to prove it. Since the limit does not exist because the left and the right limits don't equal each other, that means that, let's see, well, we're asking if the limit exists at all for this problem, so that proves the limit does not exist. All right, moving on to the next one here. As x approaches 2, looking at the graph here, as we approach from the left and the right, we are approaching the y value 1. So that one is pretty straightforward. And now limit as x approaches 4. Over here, from the left and the right, we are approaching the value -1. So also pretty straightforward. And finally, as x approaches 6, so for this one, as we approach from the left, we're going to positive infinity. As we approach from the right, we are also going to positive infinity. So we can call this one infinity, or we could call this does not exist. For this next part of the problem, we're asked if f is continuous at x equals -3 using correct notation. We have to justify our answer. So for continuity, we have to show that first off, the limit exists, the function value exists, and that those two things equal each other. So let's tackle the limit first. Limit as x approaches -3 of f of x. Looking at our graph here, as we approach -3 from the left and from the right, we're heading toward the y value -1. So the limit definitely does exist. And the function value now, f of -3 itself, well, that's going to be this solid dot up here at 2. So that exists. The problem is that the limit and the function value don't equal each other. So that means that we are not continuous at x equals -3. For this last problem part, we are being asked to write a difference quotient that best approximates the IROC for g at x equals 0. Well, the best way to approximate instantaneous rate of change is with average rate of change over as small an interval as possible. So if you want the instantaneous rate of change at 0 estimated, then let's just take a small interval that has x equals 0 in it and do the average rate of change there. So I'm thinking the interval from -0.001 to +0.001 would do the job. So we've got y2 minus y1 over x2 minus x1. So 2.001 minus 1.999 over 0.001 minus -0.001, so plus 0.001. And they just said to write a difference quotient. Well, that's what this is. We've got something minus something divided by something else minus something else. There it is.